I'd love to refer to a paper that we recently discovered. It's from a few months ago. It's temporal quality degradation in AI models. And it's basically a paper that got published in Nature. And they did a very elaborate data science experiment on 32 data sets across 4 industries. And they built 4 models for all of these 32 data sets. And then they ran 20,000 experiments per data set pair. And what they actually realized in this experiment is that 91% of models degrade after they're being deployed in production. And I would highly recommend that if you're interested in machine learning models and deploying them and post-deployment data science, I highly recommend that you read this paper. It's very accessible. But the concept that it touched upon and the proof that it provides for things that basically we as NanoML have been saying right now for a few years already, of what happens and what we've seen in practice, backed up by some theory. So that's very nice. Mafalda will share the link inside of the chat so that you can, guys can have a look. So 1 minute how the experiment is set up. What they do is that basically they take a time series data set across various industries, which goes from healthcare, transportation, finance, and then they sample 1 window of training data, a year worth of training data, and then they kind of construct like an artificial window, which they call the age of the machine learning model, which is the difference between when the model was deployed and trained and when it's actually making inference and making predictions. And that difference between that's the age, and then they just sample again some data in production. And that is 3 things that they then create. And they do that 20,000 times for all of these different data sets and all of these different models. And then they kind of measure the difference in performance between those 2. And that is what you see, or the relative performance actually. And that is what you see on this chart. And there is 2 major conclusions, which is as the age of the machine learning model goes up, it's assuming that there is no retraining, just the model staying static. The error increases, so the performance deteriorates, and also the model error variability goes up, which is also something very interesting to observe, is that how these different models, it's like random forest, gradient boosting, I think rich regression and neural network, how they react to the data and the aging as well is also very different. And that is also something that we've been noticing in practice. So read this paper if you're interested in it, but basically the takeaway point is like our models are gonna fail in production if we do nothing, and when that is happening, we need to find out and go and resolve it.